Good day. My name is Ro, and today I'll be presenting my project for ClimateWins, titled Can Machine Learning Algorithms Predict a Good Day? The goal was to use supervised machine learning to predict whether European weather would be pleasant or unpleasant. Objective and hypotheses. The main objective is simple: can we predict whether a day will be pleasant or unpleasant based on weather data? To guide this, I tested 3 hypotheses. First, if simpler models are used, then they will generalize better to unseen weather data than more complex models. Then, if certain weather stations have stronger or more complete data, then they will contribute more to prediction accuracy. Lastly, if weather data is scaled before training, then artificial neural networks will perform better than when trained on unscaled data. Data source and biases. The dataset comes from the European Climate Assessment and Dataset, which includes 18 weather stations from the 1800s to 2022. There are some clear biases. First, not all stations had complete labels. For example, Gdansk, Roma, and Tour were missing. Second, the definition of pleasant weather can vary regionally and is subjective. Finally, the dataset has limited coverage overall. All of these factors affect how well our models can learn. Optimization and pre-processing. To prepare the data, I removed non-predictive columns like date and month and dropped stations with too many missing labels. For neural networks, I applied feature scaling so that variables were on the same scale. For optimization, I used gradient descent. This iterative method adjusts parameters, eta 0 and theta 1, step by step to minimize the loss function. I also visualized how the algorithm converges, showing how different learning rates change the speed of convergence. Finally, I tuned hyperparameters. For decision trees, I adjusted depth and minimum samples, and for AND, I experimented with the number of hidden layers, iterations, and tolerance levels. Algorithms used. I tested 3 supervised learning models. K-nearest neighbors, or KNN, is simple and works well with small feature sets, but it can slow down with larger data. Decision trees are easy to interpret and capture nonlinear relationships, but they can overfit unless pruned. Artificial neural networks, or ANN, capture complex patterns, but they require scaling, tuning, and are prone to overfitting. Among these, KNN generalized the best, while ANN and trees struggled. Accuracy, KNN focus. With KNN, training accuracy started at 100% when K equals 1, but this overfit the training data. As K increased, accuracy declined, and the best test accuracy was about 30%, around K equals 7 to 9. Overall, the training accuracy ranged from 70 to 100%, while test accuracy was consistently between 25 and 30%. This shows that while the model could fit training data very well, its ability to generalize was limited, but also the best out of the other models. Summary of results to compare across models. KNN achieved the best relative test accuracy at around 30%. The unpruned decision tree overfit badly. With perfect training but poor testing results, a pruned tree performed slightly better, but still weak. ANN with larger architectures overfit, while a smaller 2-layer network performed better, reaching about 78% train and 29% test accuracy. No station reached strong predictive accuracy overall. The models topped out at 25 to 35% accuracy, showing limits in the dataset. Limitations and next steps. This brings us to limitations and next steps. Limitations include missing stations, subjective labels, an accuracy ceiling of about 35%, and a tendency for complex models to overfit. For next steps, I recommend expanding the dataset to cover more stations, engineering new features like humidity index or wind chill, testing ensemble models like random forests or gradient boosting, and using cross-validation across stations for more robust results. To conclude, this project showed the challenges of predicting something as subjective as a pleasant day. While KNN showed the most stable performance, overall accuracy was modest, and future work should focus on better features and more data. Thank you for your time. I'll be happy to take any questions.